Video we will be looking at 8E, two-step experiments using tables. So tables or arrays can be used to list the sample space for two-step experiments. If replacement is allowed, then outcomes from each selection can be repeated. If selections are made without replacement, then outcomes from each selection cannot be repeated. For example, if we have two selections made from the digits 1, 2, 3, so if we look at the left side here, this is with replacement. The first time you pick a digit, you can get a 1, 2, or 3. The second time you pick a digit, you can still get 1, 2, or 3 because you've replaced each digit. So you'll notice on the table, you have the combinations 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. On the right hand side, I have the selection of the digits without replacement. So if we look here, we have 1, 2, and 3. The first time you pick a 1, that number disappears. So you cannot get the combination of 1, 1. So all that's left is 1, 2 or 1, 3. If you pick a 2 the first time around, you can pick a 1, so you get 2, 1 as a combination, but you cannot get 2, 2 the second time around. If you pick a 3 the first time around, you can get 3, 1 and 3, 2, but you cannot get the combination of 3, 3. The key idea here is with replacement, you can get duplicate numbers. Without replacement, you cannot get duplicate numbers. Let's try this question ourselves. A fair six-sided die is rolled twice. Find the probability of obtaining the outcome 6, 4. So to start off this question, I need to draw my arrays table. So now let's fill in our combinations. Okay, so as you can see, we now have our arrays table. The first number represents the first row, and the one on the left side represents the second row. So these are all the combinations you can have if you roll the die and write down the combinations. In part A, this is asking us to find the probability of the outcome 6, 4. So we can see the outcome 6 and 4 just here. So the first roll needs to be 6, the second roll needs to be a 4. We only see this one time. Therefore, the probability of obtaining a 6 and 4 will equal to 1 out of our total outcomes. So 6 by 6 will give us 36. So 1 over 36. In part B, this is asking us to find the probability of a 3 and 2 or a 2 and 3. So let's have a look for 3 and 2 or 2 and 3. So 3 and 2 I see once here, and 2 and 3 I see once here. So therefore, we need to add them together. So it will be the probability of finding a 3 and 2, which will be 1 over 36, plus the probability of finding a 2 and 3, which will also be 1 and 36. So this will be 2 over 36, which simplifies to a 1 over 18. In part BII, this is asking us to find the probability of a sum of at least 9. So sum at least 9. So to work this one out, we first need to have a look at what numbers will be 9 or above, which combinations. So let's highlight everything that will add together to at least 9 or above. So you got 3 and 6, 4 and 6, 5 and 6, 6 and 6, 6 and 5, 5 and 5, 4 and 9, 5 and 4, 6 and 3, and 6 and 4. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of 36, which will be equivalent to 5 over 18. Okay, let's look at part C. So we'll do this one up top. So part C is asking us to find the probability of a sum of 3, given that the sum is at most 4. So we cannot go higher than 4. Let's isolate everything that is at most 4. So that means that it will be all the numbers between here. Okay, so everything on top of this section. So we've got 1, 1, 2, 1, 3, 1, 1, 2, 2, 2, and 1, 3. So once again, we're looking for the probability of a sum of 3, given that the sum is at most 4. So that means that we need to look at which ones have a sum of 3. So let's highlight the ones with 3. 2 and 1 makes 3. 1 and 2 also makes 3. This will be 2 divided by at most 4. So we've got 1, 2, 3, 4, 5, 6. Okay. So our answer to that one will be 2 over 6. So the probability of the sum of 3, given at most it is 4, will be 2 over 6, which we can also simplify to 1 over 3. 2 cars are chosen from a group of 4 without replacement. Of the 4 cars, 2 are red, 1 is blue, and 1 is white. Construct a table to list the sample space. So this is what we should expect to see. So as we can see here, as they're chosen without replacement, that means that we can't get duplicates. So I've crossed out everything that we can't get 2 of. So now we need to fill in our gaps. So we are left with RR, BR, WR, RR, BR, WR, RB, RB, WB, RW, RW, BW, and that should do it. So in part B, this is asking us find the probability of obtaining a red car first and then a white car. So red, then white. So red, then white, we are looking for red and white, red and white. So the order matters in this one. So that will be 2 out of a total of 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can simplify this to 1 over 6. In BII, we are asked to find the probability of selecting 2 red cars. 2 reds. So 2 reds means that we are looking for this one, this one. So it looks like there's only 2. So that answer will be 2 over 12, which simplifies to 1 over 6. In part III, this is asking us to find the probability of selecting 1 red car and 1 blue car. So 1 red and 1 blue. So for this one, you're looking for red and blue. So that's a red and blue. That's red and blue. That's red and blue. That's also red and blue. So that tells me this will be 4 out of 12, which also simplifies to 1 over 3. In part IV, this is asking us find the probability of selecting 2 red cars given that at least one of them is a red car. So this is conditional. So probability of 2 red, so 2 R's given that at least one of them is a red car. So to work out this question, you need to find out how many combinations or total possible combinations you can have with just red. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the total is out of 10, but the question is asking you how many of those have 2 reds. So let me get a yellow highlighter. The ones with 2 reds is just this one. 1, 2. So that means this will be 2 out of 10, which simplifies to 1 over 5. So that's it for this video. Hopefully you found this useful, and I'll see you on the next one.